So what's up people of the internet and my fellow game developers. This is Rust Gaur from KNS Productions bringing to you a new Unreal Engine 5 tutorial series. In this we will be learning how to basically do many things in Unreal Engine 5, from actually programming to 3D work, environment work, character movement, character uh, basically anything that I know I will be sharing with you. So yeah, let's get started. Yeah, so starting with the tutorial, we would actually need to open up the blueprint. So scroll down, third person, blueprints, blueprint third person character. Just let me delete it. I'm actually re-recording this montage, this tutorial. Sorry, why? Because I actually turned on game capture in OBS and that did not record the full screen. And yeah, that just felt bad. So yeah, right click and create an custom event, add custom event. Let's name the event as vault or mantle. Yeah, so in this event we would actually like to calculate the location of the wall. So for calculating any location or position or thickness, height, whatever, we actually need traces in Unreal Engine 5, and it's actually really easy to create traces in the blueprint. In future we would actually bring up C++ tutorials. I don't know, I actually don't use much of C++ because I'm only learning. So yeah, so let's drag from this execute. These are called execute pins. So let's drag from this, and let's search line trace by channel. Let me close it. The start position is actually where the line trace starts. So let's get actor location. We actually want the trace to start from the actor, so let's plug this in. And the end position is actually in front of the actor. So to get in front of the actor we actually need to get the actor rotation, get forward vector. So what this actor rotation is, get what this forward vector is. So it's any actor has actual rotation is in three axes, x, y and z. So by getting the forward vector it actually gets the vector, I mean the direction of the rotation of x and y without the z axis. So by getting the forward vector we actually get the direction in which actor is rotating, so basically the forward direction of the actor. As this is only a direction, we need to multiply it to actually get some value. So yeah, and so drag out from the return value, get this multiply node, and we need to add it to the actor location. So and we this doesn't have a value yet, so right click to float. Let's do the value as 90. Yeah, so let's plug this in and draw debug type for duration. Everything else is fine. So yeah, but we need something to call the function, so let's do a debug key q. Yeah, so when we press q, let's call this event. In this event this line trace is working, so when pressed, our event was vault or mantle, so let's call vault or mantle. Let's check what happens now. These are two types of walls, so I actually want to make the vault action only on the shorter walls, so I will show you what I will do for that. So yeah, this red trace that's coming from the body is actually calculating the location of the wall. Wherever it hits, the location is set, and we would actually use that location as the wall location. If you would like, you can actually increase the distance of the forward trace by actually increasing this number. Let's actually do increase this number because it's too short. Let's do 110. So this much is enough, I would say. Yeah, so yeah, this is enough. And yeah, so let's move forward to calculate the wall location. We actually have calculated the wall location wherever it hits. Let's just set it back to 90. 90 felt better. I will show you why. Because if it's too far away from the location, we'll actually set the location as the wall location. I don't think I'm explaining very well right now, so let's just follow the tutorial, you would understand. And from the out hit, let's search break hit result. So yeah, when we expand this, we would actually get many parameters, many variables in which the wherever the line trace hits, it creates these parameters. So we actually need the location of the line trace hit. So right click, promote to variable, and this let's name this location as wall location. Yeah. Okay, the name is not changing for some reason. Let's change it from here. Wall location. Oh, we actually do have a vector in use. Let's set wall location to this point when the line trace hits something. So this condition is that the line trace hits something. So when it hits something, we will set the wall location. And then when we set the wall location, we need another trace to find out the height, which will actually come from above the wall. Come from like here, going down. So we do another line trace by channel. Line trace by channel. And this time the start is actually from above and forward to the location. Let's get the wall location. Get forward vector. Get after rotation. Get forward vector. Multiply it by value. Add it to the wall location. Add another node. Move it forward to make it cleaner. Right click, convert this to float. Let's say we want it 10 forward to the wall location, and let's say 300 upwards to the wall location, and subtract. And we actually wanted to go down below the actual, or near to the actual wall location. This is z value, so let's subtract 100. You can put any value here, it will not matter. We only need the location where it actually hits something. So let's say draw debug type for duration. Let's change the trace color to blue. So compile and save. And let's check. Yeah, so we are getting two traces, one for the wall location and one for the wall height. Yeah, so that's good. Let's create a branch. Let's break hit result, and this time the wall height is the location where it hits, the same as the wall location. Let's set the wall height, drag this location here. So if you don't have wall height and wall location, you can just right click on the location promote to variable and set the name as wall height or wall location or whatever you want. So after we set the wall height, if now we actually do need a condition in which we want to define if the wall is thick or not. Actually, wall is tall or not. I'm sorry, I said thick. Now let's create a branch. In this branch, if the I've actually calculated both these walls height. I want the maximum height for the vaulting to be slightly above this smaller wall. So I actually calculated it to be 130, the height of the wall. So let's get wall height, right click, split structure pin. So if the wall height is greater than 130, if this condition, the z value of the wall height is actually the height, because the wall height is actually not actually coordinates of the point where the upward trace hit the wall. So if the wall height is greater than 130, then we would set the wall. Let's actually create another time. Yeah, just create a new boolean variable is tall. If this condition is true, then we would set the wall is tall. If it is false, then we would set the wall is not tall. But regardless the wall is tall or not tall, we would actually want to do another line trace by channel. This line trace actually will calculate if the wall is thick or not. So if you don't want to calculate the thickness, you just want to vault through any other wall, you can actually do it, but it is good to calculate the thickness because not every animation is made for every type of wall. So if your animation is compatible, you don't actually need to calculate the thickness, but most of the time you do. So yeah, the starting position of this line trace is actually forward to the wall height. So let's get the wall height and get actor rotation. Let's move it actually forward to save up some space and make it look cleaner. Get forward vector, multiply it, add to the wall height, another add node, and then subtract. Yeah, so right click, convert this to float. We actually want it to go, let's say 70 forward, or not, yeah, 70 forward to the wall height location, and let's say the same as 300 upward to the wall height location. This is the same height, the same trace to calculate the wall height. So 100 below and 300 upward. Let's set the start and end positions. For duration, let's change the trace it color to be yellow. It would be good if it is visible. So yeah, so branch, compile. We actually don't need the bracket resolve for this because we only have to set the wall is thick or not. It's thick. So let me tell you what I'm doing here. So we have two traces, the yellow one and the blue one. So basically if the yellow one hits something, and basically it would hit the wall, for example this, the yellow one would hit something if the wall is thick. So we have set the condition, we will set the condition if the wall is thick, then it will not be able to vault. So if the yellow trace hits something, then the wall is thick. So yeah, let's actually do that. I created a variable here called as thick. Let's set it, duplicate, If this trace hits something, then it is thick. If it does not, then it is not thick. So yeah, then we actually have to do a condition if it can vault or cannot vault. So let's create a variable can vault. Regardless, regardless if this is thick or not thick, we actually have to create a branch, because we would not calculate if it can vault if it don't. So my bad, I'm actually confusing everyone right now. So yeah, the condition for vaulting is if the wall is neither thick nor tall, then it can vault. So let's get it tall, let's get it thick, let's get a not boolean, duplicate it, let's plug these in, let's get and boolean, plug this in the condition. So our condition is the wall is neither thick nor tall. I mean, the wall is not tall and the wall is not thick. If this condition is true, then let's set just drag this, set can vault to be true, duplicate this. If this condition is false, I mean, if this condition is false, then the wall is either tall or thick, then we cannot vault. Yeah. So when we can vault, now let's actually set up the animation montage part, the vaulting animation. Yeah. So I've actually downloaded this animation from a tutorial I was actually watching when I was learning. So yeah, this is the animation. Just scroll down the animation and enable the root motion for this. I will provide the link to this animation in my description, or yeah, in the description or in the pinned comments if this description does not work. You can download it from there, or you can actually download any other one, it would work regardless. So enable root motion and then just save and exit, we don't actually need it. So then right click on the animation, create anim montage, just leave the name as it is, or you can change, does not matter. So now we would actually make use of motion warping. Let's add another track. Basically what motion warping will do is just move the animation to a certain location while the motion warping is active. So let me just show you. Add notify state motion warping. While the character starts jumping, which is from nearly here, yeah, let's drag it forward to this. At this point, the character is on the wall. So yeah, just leave it there. Add another notify state below motion warping, and this is the middle part. Let's set it up to 42. You can copy my settings, or you can actually do by yourself, it does not matter. So for the last part, we want to do it and when it lands. So we would actually set 3 positions for the animation. The jumping part would be when the character is starting to jump, so we would actually set behind the wall location. And the middle part is actually when the character is on the wall, so we would set the location of this part on the wall at the wall height. And the last part is actually the landing position. So let's click on the first one. Let's change the name, warp target name, to vault start. I would just do it VS so I can type it easier. In the vault start, we actually need the character to actually go above, I mean the characters to jump. We do not want to ignore the Z axis. So let's go to the second one. Let's change the name to vault climb VC. when it's climbing onto the box. So yeah, in this one we don't want the warp rotation. Let's set the third one to the vault land. So VL. This one we don't need the z-axis or the warp rotation. Actually, we need the z-axis, so we don't need the ignore z-axis. So yeah, that's it in this anim montage. I'll just let it save the packages. Yeah, let's get back into the blueprint third-person character. So when it can vault, we actually want to so click on this add button, search for motion warping, just click it, drag the motion warping here. So from this one we would actually search add or update warp target. In this we would actually set the location that the we just split structure pin, not promote a variable, sorry. So in this one we would actually set the warp target name that we said there, just keep it exactly the same. So I would want to set the vault start positions first. The warp target location is actually behind the wall, so get wall location. Get actor rotation, get forward vector, and multiply this, then subtract. Right click and convert this to float. We don't actually need that further back, just let's set 10 units and set the warp target rotation to the get actor rotation. So we set the vault start position. I would collapse this to a node to save up some space. Actually this thing, just collapsing this to node, it just clears out everything. So keeps the project clean. So just collapse everything to nodes. You can rename the graphs to not be confusing, otherwise you can just leave them be. Collapse nodes. Now the graph is much more cleaner. We can even bring them close together. Just save so much space. Just zoom in on this. Let's continue working on it. So duplicate these 2 times. Connect the execute pins. Basically the execute pin works like a compiler, so it starts compiling from the left. When the Walter Mantle event is called, it would first line trace by channel for this one, which was our wall location. Then it would set the wall location, then it would calculate the wall height, then it would set the wall height, so on. It would go left to right, calculating everything. So yeah, continuing with the video, let's change the other target name, which would be our vault middle or vault climb VC. And the vault target location is actually our wall height. At wall height, add some height. Not exactly our wall height because it would just glitch into the wall. Let's add 10. Yeah, so vault target location is our wall height. And the vault target rotation is just get actor rotation for every case. This is the vault land. This one we have to set the wall. It would basically set it forward to the wall height. Now get actor rotation. Get forward vector. Multiply. Add. Just add these two. Move it forward. Make another add node because we actually have to subtract something. Basically, subtract node. Because we have to set the height below the wall height, so let's subtract 50 from this and right click, convert this to float. Then let's add 50, let's add 7, not 70, just yeah, 8, no, 90 on this. Yeah, now let's see. We actually have to play the anime montage we created, so select play montage. You can also make this node play anime montage, it doesn't matter. So you have to place the mesh in the skeleton mesh component, compile. Now on now the simple execute pin, not any of this. With the simple execute pin, disable input. When the input is disabled, we actually want the movement mode, set movement mode to be flying. Drop down, flying. Because if you don't set the movement mode to be flying, then the character will not go upwards and just stay there. So let's add a delay. You can add any amount of delay, but you actually should check the timing of the animation. Let me check it. It just froze. Yeah, back again. So whenever it lands, I want the input to be back. So around this, so 1.55 seconds or 5-6 seconds. So yeah, let me add a delay of 1.56 seconds. After this delay is completed, we want to enable input and set the movement mode to be walk again. Walking. Yeah, so I guess that's it for the system. Let's check. When we press Q, okay, not working. Oh yeah, we actually have to select the montage to play. Sorry. Then compile, save. Is there any issue with this? Okay, we actually did not set what target rotation is. Get actor rotation. Compile. Let's play. Let me just check it real quick. Is there an issue? Let me just check the issue real quick. So yeah, sorry, I found the issue. So actually, when we actually set the target location for the VS, so we actually set the location reverse. So when we subtract the forward vector and actually subtract the wall location from the forward vector, it actually sets a negative value which goes behind towards the origin. So the quick fix is just swap those. Just because a plus b, sorry, a minus b is not equal to b minus a. That's the issue. So let's check it now. Yeah. So this is working perfectly. So there are some glitches with the montage itself. So yeah, it's fine. My animation is actually broken, so looking like that. So regardless, the actual system is okay. So yeah, that's it for this tutorial. So like, share, subscribe, and comment down if you want more of these and type of what type of tutorials you want.